Okay, here's 8.5. A nutrition intervention trial, 382 volunteer non-diabetic subjects aged 55 to 80 years were randomly assigned to either a Mediterranean diet with a group size of 248 or a low-fat diet, group size was 134. After 4 years, 10.6 participants on the Mediterranean diet and 17.9% of participants on the low-fat diet had been diagnosed with diabetes. P1 would be the true portion of adults like those in the study who would be diagnosed with diabetes when following Mediterranean diet, and P2 would be the true portion of adults that would be diagnosed when following a low-fat diet. So the parameter of interest, simply P1 minus P2, which is the true difference in proportions of adults like those in the study. That's going to come important in a second. Study who would be diagnosed with diabetes. Who would be diagnosed with diabetes. And so we're going to go Mediterranean diet minus, what they call, just count the low fat. Okay, conditions met. I have a problem with this one where they say random. Random for us has always been so we can generalize to a larger population. We can't do that here because these were volunteers, but they are saying the random assignment was done. But that lets us draw a conclusion about causality. So yeah, that's weird to me that they would say it that way. Like, you can draw a conclusion to groups like it, and that's what they do. Adults like those in the study is what they keep going at, so that's why we can get around the random thing here, but we do have random assignment of treatments, but that condition is different to me, so that's a little weird, honestly. 10%, we're going to assume 248 and 134 are less than 10% of 55 to 80-year-olds who are non-diabetic. Okay. Large counts for normal. We're going to have 248 times 0.106 from here. And that is greater than, we can just say that, greater than or equal to 10, and 248 times 1 minus 106, 0.106, is also greater than or equal to 10, but we have to do it with the other one too. There's that weird little glitch again. And so we're going to now use 0.179 and 134. 134 times 0.179 is greater than or equal to 10, and 134 times 1 minus 0.179 is greater than or equal to 10. Okay, Pew Research Center randomly selected 5,733 adults for a survey about their social media usage. Among the respondents, the proportion who used TikTok was 0.35 for those with a high school diploma and 0.226 for those with college graduates. 100% confidence interval was for the difference in proportion of U.S. adults who use TikTok. High school diploma versus college graduate is 0.84 to minus 0.084 to 0.164. Interpret the confidence interval. We are 99%. These get tiring to write out. I apologize. I know for you too. 99%. Easier if I could type it. Confident. That the interval from 0.084 to 0.164 captures the true difference in proportions of all U.S. adults who use TikTok, high school diploma minus college graduate. Is there convincing evidence that the true portion of all adults with a high school diploma that use TikTok is greater than the true portion of all, yes, that adults with college? Yes. The entire interval is positive. So all plausible, not possible, plausible differences are positive. Easy enough. CDC conducted a survey, randomly selected U.S. adults about physical activity. Among the respondents, 22% of 1183 adults living in the South met with recommended daily amounts of physical activity, while 28.5% of the 1,023 adults living in the West met the recommended daily amounts. Construct and interpret 95% confidence interval. Here we go again. We're doing the whole shebang, the 4 C's. We're going to choose, we're going to do a 2-prop Z interval for P, let's call it, what are we doing, the South PS minus PW. The true difference in proportions of adults true difference in proportion of adults who meet, and who meet the recommended amounts of physical activity, South minus West. It's just that right there. So we're doing, check. So randomly selected. I'm going to run out of space here, so I'm going to leave these here, randomly selected. We can assume these are both less than 10% of all adults in those areas, and 22% of this is greater than or equal to 10, and 1 minus 22%, or 100 minus 22% of that is also greater than or equal to 10. 20.5% of this is going to be greater than or equal to 10, and 1 minus 0.285 of that is also going to be greater than or equal to 10. So we got all the conditions. So now we might as well just jump in the calculator. We do need to figure out 22% of 1183 and 26.5. Is that what it says? Yeah, 28.5. So real quick in the calculator, we need to do 0.22 times 1183, so about 260, and 0.285 times 1023, 260 and 292. So menu, statistics, confidence intervals, 2-prop Z interval. So what was it? What did I say? I've already forgotten. 260 and 292. $260 out of 1183, and then 292 out of 1023, and they want 95%. Okay, so there's our lower negative 0.1 to negative 0.03, and there's P diff. So let's see what we need here. Move this over here, because we need to put all the stuff, calculate PE plus or minus MOE. So it's point estimate is P diff in your calculator, negative 0.066 plus or minus 95%, so 1.96. And we got the really long one here, 0.221 minus 0.22 over 1183 plus 0.285 times 1 minus 0.285 over 1023. And that gives us an interval of negative 0.1 to about negative 0.03. We are 95% confident that the interval captures the true difference, and we can go right back to that, the true difference in proportions of U.S. adults who blah, 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 blah. Okay. Does the interval provide convincing evidence that the true proportion of U.S. adults meeting their recommended daily physical activity is lower in the South than it is in the West? So our entire thing is in the negative. So all plausible proportions, difference, there's not an I, in props are negative. So it is likely that South is lower in the South than the West. All right. Number 4. Suppose a 95% confidence interval is constructed for the true difference in proportions between two independent groups. The sample proportions show that P hat 1 minus P hat 2 is 0.014. Assume that all conditions have been met. Give a margin of error that would make each conclusion valid. If the conclusion is not valid for any margin of error, explain why. So basically what? We would need to get to 0.05. So you do this, you do negative 0.14. Where's my negative sign? To get to 0.05, so 0.14, I think I did that wrong. So negative 0.14 minus 0.05. We need at least a margin of error. So you can kind of do just negative, the distance between the two. Why am I writing that? Minus 0.05. How far apart are they? You need at least a margin of error of 0.19. And plus or minus 0.19. Is plausible, so that would have to be plausible. There is convincing evidence that it's greater than 0. This can't happen. The interval is going to contain negative 0.14. All the entire interval would have to be positive for that to happen. There's convincing evidence that they equal. To get convincing evidence, you can't do that. Can't be done with an interval at all. You can't prove anything about one value with an interval of essentially infinite values. And interval. And there's not convincing evidence, any margin of error that would put this above 0. So, at least a margin of error of 0.14. Because then we'd straddle 0, we'd have positive and negative numbers. And that would mean that this may not be true. All right? Okay, down to the multiple choice. Large company selects a simple random sample of 250 employees and asks them whether they prefer first shift, second shift, third shift. The sample, 54% prefer the first, 38 blah, 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 blah. The company wants to construct a 90% confidence interval, estimate the true difference in proportions. Which of the following reasons best explains why this is not appropriate? Well, this was one sample of all their employees. We need 2 independent samples to do a difference. They got to come from 2 separate places. So the responses were not collected by 2 independent samples. You've got to get them from 2 places. You can't compare this one to this one. You can find a confidence interval for the true proportion of this, and you can find a confidence interval for the true proportion of that, but you cannot compare them and make the difference of them if they're coming from the same sample. They're not independent. Okay, a 16-ounce candle is expected to burn for at least 60 hours. But Franzi, that's a great name, has observed that the brand of candle may influence burn time. To investigate, she randomly selected 80 16-ounce Wonder Wicks candles and 80 16-ounce Flicker Fusion candles and burned them continuously. Of the Wonder Wick candles, 52 burned for at least 60 hours. The Flicker Fusion, 66 burned for at least 60 hours, which the following gives a 90% confidence interval. True difference between Wonder Wicks and Flicker Fusion for 60 hours. Assume all conditions have been met. So we need to do, we need to do, was it 52 of the first one? 52 over 80 minus 66 over 80, which would be negative, we don't even need that. So what is 52 over 80? Don't have my phone calculator right now. I'm guessing it's 0.65. Oh yeah, they're all going to be 0.65 and 0.825. So let's do some things here. 95%. So that's good, that's good, that's good. Because look at, I'm going just by all these are the same. So that's okay. So these two are out because we don't use 1.645. This would be true if both of them had the same probability, but they don't. So this doesn't make sense. So we can get rid of that one. One of the tricks here, 0.825, let me see, what am I seeing a difference here? Oh, this is weird. Yeah, you can't just combine into one whole package. So that leaves us basically with A. This is the right one. Okay, there you go.